Okay, ladies and gentlemen, welcome to Tuesday. I want to briefly run through some of these slides for you, and we want to talk about the life cycle of a star. Now, I realize stars are not considered to be living organisms, but astronomers just refer to this as the star's life cycle. The main objective that I have for you today is actually two of them. Number one, to understand and to know that a star's cycle, in other words, its path, if its evolutionary or changing path over time, is determined by its mass. Larger mass stars will take one route of evolutionary change, and lower mass stars, like our sun, will take another route. The second item I want you to make sure you understand is that inside the core of a star, nuclear fusion is taking place. And that fusion process will start with hydrogen fusing into helium and releasing quite a bit of energy. Now, let's talk about our sun, just as an example. Our sun is an average to really a smaller size star. Our sun will continue to fuse hydrogen into helium. When it's doing that, we call it a main sequence star. So a main sequence star is just a star that has enough hydrogen, it's fusing helium, and it's producing enough energy so it doesn't get crushed by its own gravity. Now, sooner or later, that hydrogen is going to run out. When it does, the star's got a lot of helium laying around, so it tries to fuse the helium, but it's not going to be enough, so the star sort of collapses on itself and expands outward. From there, it expands outward further into a planetary nebula, and then, as our star will do, it becomes a simple, little, very cold, very unassuming white dwarf. A star with a tremendous amount of mass will go another route. A massive star will still be a main sequence star, obviously, because as long as there's hydrogen to fuse and the gravity is not crushing the star, it stays at stellar equilibrium, and we say that's a main sequence star. But over time, when the hydrogen runs out, then the star will fuse helium. From there, it can continue on to fuse carbon, silicon, all the way down oxygen. When it gets to iron, when it starts fusing iron, that's the end of the line, because iron is the last step in this fusion cycle for massive stars. When that happens, the star collapses on itself and then expands outward very rapidly in a very violent supernova. Now, after the supernova, after the star begins to cool down, it can become a neutron star, which is just what it says, stars packed with very dense neutrons, or it might even become a black hole. So that is the evolutionary life cycle, if you will, of a star. But again, it's all about the mass of the star. Remember, the star would love to crush itself in. There's always this constant tussle or this constant battle between gravity and thermal pressure. As long as there is fusion taking place, that energy is moving outward and it balances the inward push, if you will, the inward pull of gravity. And that's what we call stellar equilibrium. And again, that is a main sequence star. It's in stellar equilibrium. If you have really, really, really large stars, 25 times larger than the mass of our sun, they will go through a variety of stages. As we know, hydrogen fuses to helium, helium can fuse to carbon, carbon to oxygen, and these elements are all being produced in the core of stars by nuclear fusion. And that's why sometimes you'll hear an astronomer say, we are all made of stardust. Because when these stars eventually explode and expand out rapidly, they throw all of these elements out into space, and they are used again in formation of new planets and new stars. As we begin, all stars are going to begin when they can start to fuse. The first step of solar evolution or solar life cycle of a star is something called a protostar. We'll stop there for right now. Remember, main factor is mass, and fusion has to happen for a main sequence star. That's it. Have a great day.